Welcome, everyone, to our recording of how to construct an irrational number, specifically radicals. We're going to start with the square root of 2. How do you do a construction using only compass and straight edge? Here we go. Suppose you have a number line, and then I spot you the numbers 0 and 1. And these are somewhat an arbitrary length, but just to show that it doesn't matter what length it is. As long as we have a unit of length. So we have a unit of 1, and we need to make the square root of 2. Well, the basic idea will be that we're going to make an isosceles triangle. Because if we have a right triangle with sides 1 and 1, by Pythagorean theorem, we know that this hypotenuse will have to have the square root of 2 as its length. And so the question is, can we construct a line with a 90-degree angle, a perpendicular line, and make that the size, the length of 1, so that we can connect them and make the square root of 2. So let's do that. Thankfully, we have a nice little compass tool right here. All right, and we're going to copy this length, which is length 1. So we're going to make it the same as this right here. And actually, before we do that, we could even just do any arbitrary length, just to find. Arbitrary means at my whim, according to whatever I want. So nothing predetermined or, necessary. So we can do this, and then from this point here, from the points on the circle, we can make, again, some arbitrary length. Let's change the color so we can distinguish. And this is a little bit wide, but we can kind of make. We don't need that much. Maybe about like this. And then we're going to swing this around on the top. And we're going to do this here. And we're going to keep that same length and put that on the other side. And right there. And basically what we're going to do now is we're also going to get that same arbitrary length from this side, and we're going to connect these points. And what that will do for us is we can make a perpendicular line, which was our goal. And so we just connect these points. So we have this one here, and I'm just going to go through that point and give ourselves a little extra length because we're going to need it. I don't know how much, but this should be enough. And now we have created a perpendicular line. Now we just have to measure the length of 1. So we're going to go back to that compass. And we're going to measure the same length right here, which was that 1 unit. And let's try to get this exact. The angle is a little. I think that'll be satisfactory. And so that's a length of 1. And so we're going to copy that length to right here. And now we know that those 2 points will be exactly square root of 2 apart. So here's what I mean. If we connect this length here, make it a little thicker. This point of intersection right here, connect it to this point of intersection right here. Come on, give me that 45. There we go. That means that this green line segment, the thicker one here, is going to be the square root of 2. So this right here will be the square root of 2. And we can transfer this length, if we want, onto the number line, which may come in handy later. So what I mean is that we can take the compass and we can copy this length. If only I could fit that. Let's see. So we put one end at this point of intersection and the other one not quite that much. About like that, and it's slightly more. There we go. That looks pretty good. Do you see how this is now the square root of 2? So this length from the compass is the square root of 2. So I can put that pointy part at 0, and I can swing it through here, And now I know that this length will be the square root of 2. The point of intersection. This on the number line, right? This point right here is square root of 2. So, hey, I have square root of 2. So that's great. I have square root of 2. What about other square roots? Well, another necessary one is square root of 3. Now, there's a couple ways that we could construct square root of 3. We could just use this square root of 2 and a length of 1 and make those into, we could literally just connect these sides right here. I'll try to pick a unique color. So remember that this height here is at 1. In fact, I could label it as such. This point right here is 1. And if I connect this point to root 2, what is that hypotenuse there? Let's think about it. This is 1. This is root 2, this whole side from here to here. Sorry for the... I can do better. Yeah, I'll pick a different color, purple. So I'm saying this purple, and that purple side is root 2. And the height is 1. So guess what the hypotenuse is? It would be, if this is our right triangle, then we have 1 squared plus root 2 squared. And this will be our c, right? This third side equals c squared. And if you do the math on that, you get 1 plus 2 equals c squared. And so therefore 3 equals c squared. And so therefore the square root of 3 equals c. So we just found the square root of 3. And hypothetically, you could just transfer that length onto the number line again, connect the hypotenuse, and just keep adding 1 as far as you need it. And that will construct any square root that you have. But, you probably don't want to go 1 by 1 by 1 until you get to, like, square root of 47, right? So if you want to do square root of 47, is there something else that you can do that's maybe faster? And maybe 47 is a little bit too big. We can start off with something smaller. We talked yesterday or the other day about square root of 7. So let's talk about how could we construct the square root of 7 if we, for example, already know the square root of 3. And then we can kind of build off of that. Or even the square root of 8 or some other numbers. So, and one lesson I like to remind everyone is that square root of 1 plus square root of 4 is not the square root of 5. It doesn't work, right? I remember it does not work. Because, as you know, square root of 1 is just 1, and square root of 4 is just 2, and they add up to 3, which is actually the square root of 9, and that is definitely not, that is definitely not the square root of 5. So I hope it's clear to everyone that you can't simply add square roots unless we use the Pythagorean theorem for the triangle. In a triangle, those lengths do work. For example, if I have a right triangle and I have, let's just use those same numbers, square root of 1 and square root of 4, then this hypotenuse will be the square root of 5. Because it's the first one squared, square root of 1 squared. The square undoes the square root plus root 4 squared. Well, that's going to be root 5 squared. And so we know that the third side is root 5. Okay, so we can use that knowledge to just put to basically add any two numbers to get a larger number. So if you want to find the square root of 7, hey, square root of 4 plus square root of 3. Why not square root of 5 and square root of 2? Because square root of 5 is a little harder to find. Square root of 4 is pretty easy. Square root of 3 we already have. We can use those to get square root of 7 rather than 1 plus 6. Find the square root of 6 and add 1. That would be a little cumbersome. So let's do the square root of 7, and we're gonna use the square root of 3 that we already found. So we'll just assume that we already know how to get the square root of 3, and we'll just use that to add. Now, square root of 3 plus square root of 4, square root of 4 is just 2, and 2 is really easy to get, because if you have 1 on the number line, you just have to swing it over and double up, and you'll get the 2. So we have a 1, and I'm going to have to extend this number line here, this original number line that I had. And I'm going to copy that length of 1. I hope that is acceptable to everyone, that would be about 1. And I just copy this over here. And now I have 2. And I also have the square root of 3, which remember is that magenta line, that C there. In fact, I can erase some of this to get rid of the distractions. So that magenta line there is square root of 3 if it had been copied fully. And what we need is we actually need it on the origin if we have that 90-degree angle. So let's do that. I'll keep this. I guess I'll keep this green. That's fine. So we're going to extend this out because we need more room. Oh, are we going to be able to fit it? I don't think so. Unless, through the magic of Kami, we can move it down. Oh boy, I hope that's not going to be arbitrary again. I wish I could move them all together.
Yeah, you could. There's the thing on the left corner.
I wish there was a way to select more than one line.
Left corner.
Left corner?
Yeah, down.
Oh, yeah. Ah, brilliant. Yes, you get the Genius Award. Thank you. Now I might be able to fit it. Wow, I learned something new while I'm doing a recording. Okay, so that length is 1. So now we're going to copy that length. We're nearly done. Once I finish the square root of 7, I'll take a break and make a new video. So this intersection right here down to... Oh, it doesn't work that way. Okay. I wonder how far it can go. Oh, wait. Did I need square root of 3? Yeah, I did. Square root of 3, yeah. I hope it reaches. Okay. Now, I hope you all find this acceptable, that you all agree that the width of this compass right now is square root of 3. I know some of you thinking, well, it says square root of 2. What are you talking about? Yeah, no, that's on the number line. That's not the distance between the points of the compass. So this compass is, in fact, square root of 3. And what I need to do now is I need to make that the height of this. So we're going to put this down here. No, I need more line. It's okay. I'll make more line. Zip. And like I said, I can increase this line here. And now I hope everyone agrees that this length here is the square root of 3. And that this length from here to here is 2, aka root 4. And therefore the hypotenuse will be the sum of those as a square root. So what color should I use? I'll just use red. You want purple? Alright. So from here to here, that's purple. And this length right here is the square root of 7. And you can swing that down and copy that into the number line if you want. I think this is satisfactory. I think this works. So that's how you construct the square root of 7. And if you want to do any other square roots, you simply put them in a triangle. So larger numbers, you simply, if you want the square root of c, you just have the square root of a and the square root of b. And if the square root of a plus the square root of, if a plus b equals c, I should say. If a plus b equals c, then you can figure out that square root. So that's it for me.